Now let's see this one. It is a 3 by 3 matrix, and now we are supposed to find out characteristic roots. Characteristic roots means eigenvalues. Characteristic roots and characteristic vectors. Characteristic vectors means eigenvectors. So for a 3 by 3 matrix, we are supposed to find out characteristic roots and characteristic vectors. So how can we find out? Since it is a 3 by 3 matrix, we are supposed to find out how many eigenvalues will be there. The number of eigenvalues will be 3. In case if there are no repetitions. Sometimes what happens is there will be repetitions, and then you can think of it as less number of eigenvalues. But here in general, since it is a 3 by 3 matrix, we are supposed to get three characteristic values, which is eigenvalues. So first step is find out the eigenvalues of this. How can we find out? Write the characteristic equation, which is nothing but the determinant of a minus lambda I equal to 0. So I am just putting a minus lambda I is equal to 0 here. Then I'll get this equation. Yes, I got this equation. Now this equation, if you simplify this, if you write this and simplify it, you'll also get this. Okay, so I am just directly writing it. Now from this one you can understand that this equation can be written like this. Therefore the eigenvalues are 0, 3 and 15. We have 3 eigenvalues here. The second step is to find out the eigenvectors. How can we find out the eigenvectors? Take each eigenvalue and substitute it in the equation, and you try to get the eigenvector. So the eigenvectors for lambda equal to 0 are, see, for lambda equal to 0 I'll find it out once, and then for lambda equal to 3 I'll find it out, and lambda equal to 15 I'll find it out. So eigenvectors for lambda equal to 0 are a minus lambda I into lambda equal to 0. In place of lambda I am going to put 0. So when I put 0, what do I get? A into x equal to 0. So I am just following the method that we have seen in the earlier examples. So what is it? A minus lambda, it is nothing but 0 here, into x equal to 0. Therefore a into x equal to 0. So why is x containing 3 elements x1, x2, x3? Since A is a 3 by 3 matrix, x will be a vector which is 3 by 1 vector. Therefore x1, x2, x3 are written here. Got it? Now just for the sake of simplicity, I'm just simplifying it. See, from here on I'm not doing anything new. Okay, from here on it is simply the method of solving system of linear homogeneous equations, which we have seen earlier, right? So I'm just doing that method. So what should I be doing? R1 and R3 I'm just exchanging them. Yes, I exchange them, and then I am applying these transformations. One transformation is R2 is replaced with R2 plus 3R1. So why? Because I am just multiplying this with 3 and then adding the result to this. Then I'll get 0 here. That is why I am doing it. And then R3 is replaced with R3 minus 4R1. If I multiply this with 4 and subtract it from this, I'll be getting 0 here. Therefore I got 0 here in these two places. So I'm trying to make as many values as zeros as possible. Now if you see this one, these two, if you compare R2 and R3, it is clear that you can make them as zeros, one of them as zeros. So I'll try to make R3 as zeros. Just to make the row 3 as zeros, I'm replacing row 3 with row 3 plus 2 into row 1. So 2 into row 1, if I add it to row 3, I'm going to get 0 here and 0 here. Got it? Now if you observe this matrix, this is in the form of Ax equal to 0 form only, right? And now since there is no space, I didn't write it, so I'll just erase it and I'll complete it further. But you just remember this one. So we got this one as this entire equation is resulting this. Now from this equation you can see that the rank of the quotient matrix R equal to 2 and the number of variables n equal to 3, and so n minus R is going to be 1, which means we are going to have infinite number of solutions. Therefore for this particular value of lambda equal to 0, we have infinite number of eigenvectors. Now how to find out all those eigenvectors? We have to solve this. So how to solve it? Now n minus r, which is nothing but 1 unknown, should be given some initial random value, and using that value we are supposed to evaluate the remaining two values, right? So let us assume that, okay, I'll erase this and I'll continue this. Just remember till here, what happened till here, we are able to get finally these equations. Now I'll take it from here. Okay, now I'm taking it further from here. So after solving this equation a minus lambda x equal to 0, after applying some transformations, I got this equation. The quotient matrix is this and variable matrix is this, and here we have 0. So if you find out the rank of this matrix, the rank of this matrix is nothing but 2. What is the rank of the matrix? You know that, right? So the rank of the quotient matrix, let's call it as r equal to 2, and the number of unknowns are 3. Therefore n minus r equal to 1. 3 minus 2 equal to 1. What does it mean? In order to, so okay, whenever n minus r is greater than 0, we know that there are infinite number of solutions. We are supposed to find out all the solutions, which means for k equal lambda equal to 0, we have infinite number of eigenvalues, eigenvectors. How to find out this? So for n minus r, that is here one unknown, you give some initial random value, and in terms of that random value you find out the other values, right? So let us assume that x3, why n minus r equal to 1, therefore I am assuming that only one value x3 equal to k, right? And then I am just writing these equations here. So one equation is 2x1 minus 4x2 plus 3x3 equal to 0, and the other equation is minus 5x1 plus 5x2 equal to 0. 5 plus 5x3 minus 5x2 plus 5x3 equal to 0. Then what did we get here? x2 equal to x3. Already we decided that x3 equal to k. Therefore, since x2 equal to x3, we got x2 equal to k. Now we know that x1, x2 and x3 equal to k. You substitute these values in the first equation. Here if you substitute here k and here k, we are going to get x1 equal to k by 2. Therefore, the eigenvectors corresponding to lambda equal to 0 is nothing but x1, x2, x3, and we know that x1 equal to k by 2 and x2 equal to k and x3 equal to k, and if I just substitute them here, I got this. So this set of eigenvectors corresponding to the eigenvalue lambda equal to 0 is this one. Understood this? Now we have to find out the set of eigenvectors corresponding to lambda equal to 3 and then lambda equal to 15. Got it? Okay. Now let's see the next part. We have found out the eigenvectors for lambda equal to 0. Now we shall find out the eigenvector for lambda equal to 3. How can we find out? Same thing, a minus lambda I into x equal to 0. So in place of lambda and x, you are supposed to substitute the corresponding values. So how can I substitute them? So in place of lambda you substitute 3, and in place of x you substitute this x1, x2, x3. That is what we wanted to find out. And in place of a you substitute the given matrix A. These are the three things you are supposed to substitute. Then we are going to get this equation. I got this equation. Now you apply some transformation in order to solve this. It is nothing but system of homogeneous linear equations. So first transformation is row 1 is being replaced with row 1 plus row 2, which means you add these two and you substitute the result in place of row 1. Then what did I get? If I add these two, then I got minus 1, minus 2, minus 1. And after that, using this 1, you try to make these two as zeros. For that reason, row 2 is replaced with row 2 minus 6 into row 1, so that I can get 0 here. And similarly, row 3 is replaced with row 3 plus 2 into row 1, so that I get 0 here. Yes, I got zeros here. And you can see that these two elements can also be made 0 if you try to add or replace row 3 with row 3 plus 1 by 2 into row 2. Therefore, I got zeros here. Now, if you observe this, I got this final equation simplified this way. Now, from this you can see that the rank of this matrix are equal to 2, right? This one, the rank of this one is 2, right? And then you can see that the number of variables is 3. So, n minus r in this case is 1. So, what does it mean? We have infinite number of solutions possible. Therefore, even for lambda equal to 3, we have infinite number of eigenvectors possible. What are all they? In order to solve that, we are supposed to assign n minus r unknowns some random value. So what is n minus r here? One unknown. So take any one of these unknowns, x1, x2, x3, and you assign it some constant value k, and in terms of that you are supposed to solve the remaining. Okay, I don't have space here, I'll just erase it and solve it now. Now see this, we already seen that n minus r equal to 1, which means one of the unknown has to be given some value, and in terms of that we are supposed to find out the other unknowns. let us say that unknown is x3 equal to k, right? After substituting x2 equal to x3 equal to k, let's find out what are the equations that we finally got here. We got only two equations here. The third equation is not possible because all are zeros. So what are the two equations? One is minus x1 minus 2x2 minus 2x3, minus x1 minus 2x2 minus 2x3 equal to 0, and the other one is 16x2 plus 8x3 equal to 0. Now in place of x3 you substitute k. So in this equation, in place of x3 you substitute k, then I got x2 equal to minus k by 2. Now taking this equation, in this equation substitute the values of x2 and x3, and we got that x1 equal to minus k. Therefore x3 equal to k, x2 equal to minus k by 2, and x1 equal to minus k. If you substitute them in place of x1, x2, x3, I got that x1, x2, x3 equal to minus k by 2 and plus k. So you just take out k as common, then we are going to get k into minus 1 by 2 and 1. So what do you understand from this? The set of eigenvectors corresponding to the eigenvalue lambda equal to 3 is k into minus 1 by 2, 1. Okay. See this? We know that already we have seen earlier, we have seen the eigenvectors for 0 and 3. Now we want to see the eigenvectors for lambda equal to 15. So the procedure is same. In place of lambda here you are going to substitute 15, then I got this equation. So this is a kind of a minus 59, this one, and then x and then 0. So it is a kind of ax equal to 0, the same thing, set of linear homogeneous equations. So how to solve it? Try to apply some transformations on this, simplify it, find out the rank, and then go ahead. So fine, I'm just trying to apply some transformations on this to make most of the elements as zeros. First transformation is r1 is replaced with r1 minus r2, then I got this, and the next transformation is r2 is replaced with r2 minus 6r1, and r3 is replaced with r3 plus 2r1, then I got most of the elements as zeros. Now if you look at this, the rank of this particular matrix is 2. Rank of this one is 2, and the number of unknowns is 3. So now we know n minus r is 3 minus 2, which is 1. Therefore there are infinite number of solutions, which means we get infinite number of eigenvectors for lambda equal to 15, and in order to find it out we have to substitute for one unknown. Why 1? Because n minus r equal to 1. For one unknown we have to substitute some random value, and from that we have to solve the other equations. Okay, so now what we shall do is I'll erase this, and I'll substitute in place of one variable some constant k, and using that I can derive the values of the other variables. Okay, I'll just erase it and do it here. Now we have just seen this one, which means we got till this. So we are able to simplify this equation ax equal to 0. We are supposed to solve it. How can we solve it? We have to find out n minus r. We found out that n minus r equal to 1. Therefore one of the unknowns is going to be assigned a random value, some value k, and using this I am going to find out the other values. So if you see this, we have two equations in this matrix equation. So one equation is minus 20x2 minus 40x3 equal to 0. You have to be careful here. It is not minus 20x1 and minus 40x2. It is minus 20x2 minus 40x3, because 0 has to be multiplied with x1, minus 20 has to be multiplied with x2, minus 40 has to be multiplied with x3. Therefore minus 20x2 minus 40x3 equal to 0. From that we get x2 equal to minus 2x3. So from that we get x2 equal to minus 2k, because x3 we already assumed that it is k. So x2 we got it as minus 2k. And then the other equation is minus x1 plus 2x2 plus 6x3 equal to 0. Minus x1 plus 2x2 plus 6x3 equal to 0. So from this you can see that x1 equal to 2x2 plus 6x3. So in place of x2 you substitute the value minus 2k, and in place of x3 you substitute k. Therefore you are going to get 2k. Therefore x3 equal to k, x2 equal to minus 2k, and x1 equal to 2k. So you can substitute these values here, and when you pull out k as common, we are going to get 2 minus 2 and 1. So these are the set of eigenvectors for the eigenvalue 15. So we have solved for all the eigenvalues. What are the corresponding eigenvectors? In GATE exam, they might not ask you this entire question. They will ask you a part of it, which means they will either ask you to find out eigenvalues, or they'll give you one eigenvalue directly and they will ask you what will be the corresponding eigenvector for that, something like this, right? So it is better that you solve the questions while practicing using this model, which means try to find out eigenvectors as well as eigenvalues, even though they didn't ask it, but in exam they'll ask you a small part of it. Don't worry about it. It is not going to take a lot of time in exam. In exam you are not going to do this big, it will be small only. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.